Hello, everyone. Welcome back to Subnet Magazine. Today, we're excited to speak with Brian McCrindle. Brian is one of the powerhouse developers behind Subnet 9 IOTA and a machine learning research engineer at Macrocosmos AI, a group working on decentralized AI and the BitTensor protocol. Recently, he's joined forces with MacroZack as the founding engineer of BitTensor's first crowdfunding platform, BitStarter. Welcome, Brian.
Wow, look at that. What an intro. Welcome. Thanks.
Thank you. To start us off, please tell us a little bit about yourself and your journey.
Sure. Yeah. I've done a lot of random stuff. So academically, studied engineering physics, did that sort of thing for a while, for like 4 or 5 years, did more like optics and lasers and all that fun stuff. My master's, I sort of transitioned into wanting to do more like data science, machine learning things. So then I did a master's in biomedical engineering. This was like focused on like, again, image processing, statistics. I was in like the lab all the time, like measuring either myself or somebody else, like just getting data. So that was really fun. And then after that, I sort of like bridged those two worlds. And I started working with a close friend of mine now, who is still my boss. I'll never get rid of him, who's Stefan Cruz, who goes by Crux on BitTensor. But he hired me for my first job, which was like a combination of machine learning and physics, transitioned into doing some other stuff, worked at the OTF, and now I work at Macrocosmos as a founding engineer and starting this new venture with Chris. And yeah, so that's sort of like the whirlwind of it. Kind of nuts to say it all at once, but
Fantastic. So I know it's all outlined on your GitHub, but your academic background, the bachelor's in engineering physics and a master's of applied science and electrical and computer engineering, both at McMaster. You share that you are also a MyTax scholar working on physics-informed machine learning with solid-state AI to improve the growth of semiconductor-based lasers. So can you explain that research for any of us that are like unfamiliar with this field, and what were you doing with semiconductor-based lasers?
yeah, I realize as you say these things, like my whole CV is just filled with buzzwords. Like it's just a buzzword paper. Okay, so for some context, a laser, you can make it out of gas. You can also make it out of a semiconductor. It's all about just exciting electrons and getting light out of it. There are low efficiency lasers, there are high efficiency lasers. There are lasers that you need to create specific types of light, and you need to manufacture them in specific ways to be able to do that. Right? If you want to create a laser at, let's say 1200 microns, how do you actually do this? Right? It's about a material property. You need to, think of it as like Lego. You got to put a couple things together so you can actually build a block, and then that thing creates light, and then you're happy. Creating these things can be hard, like straight up, and you need a lot of different statistical modeling, machine learning modeling, expertise to come together to actually be able to create something. Like it's very, very difficult to create something on a wafer. You need to deposit a bunch of material, and then this thing needs to grow, and then you need to cut this thing, and then you actually need to, the manufacturing process is already very low yield. And so what we were doing at the startup was basically trying to improve this process, going from a yield of, let's say, 90% to 90.2%, right? Or 91%. Even 1% is a ton of money that you can save. And that 1% involves modeling and lots of engineering background and physics background. Like myself, I did engineering physics, but even Stefan, he has a PhD in physics. And the co-founder or the founder of Solid State AI is also a PhD in engineering physics. So it's like you have 3 physicists together doing machine learning, do data science, and it's like, okay, even it's still hard. So like, that I hope that's a little bit of context.
Definitely. And then how did you find your way to BitTensor? And what made you feel that this was the best way to build AI?
Yeah, that's a hard question, because I feel like most people who are early in BitTensor got into BitTensor in very weird ways. The story goes, and I've sort of alluded to it. So Stefan, he was my boss at Solid State. He then became, when I decided to break up with him and leave to a different company, he also decided a few months later that it was like, okay, it's his time to go. He found himself in one way or another as the CTO of of the Open Tensor Foundation. So he was like one of the original people working on SN1, working with Jake, working with the engineers there. You know, and he's having a grand old time getting adversarially attacked. I am on a soul searching adventure down in Mexico. And he was living in Mexico at the time. And I just texted him up. I hadn't seen him in a while. I was like, hey, Stefan, like, you know, let's just hang out. And I go down, I hang out with him, and he starts telling me about this BitTensor thing. I didn't have a job at the time. He's telling me all about it, whatever, have a few beers. It's over a fire. And then in the morning, I sleep underneath his stair set because he has a little tiny little place I can sleep. And in the morning, I'm like, actually, I think this is cool. Like, send me some more information. One thing leads to another. He gets me an interview with Jake. I'm working at Open Tensor Foundation, and I didn't know anything about this stuff. Like, I am, of course, interested in machine learning, of course, interested in AI, but I don't know anything about crypto. I don't know anything about any of this shit. And over time, it was the right thing to be doing at that time. I learned a lot and have grown a lot. And we can go into that if you want, but that was my adventure into it. And you know, you learn early on. You're like, oh, BitTensor has a lot of potential to build the right things, although conditionally quite hard to do it in the right way. But it has a lot of the potential to build the right technology for the future. So I think that's what keeps someone like myself around, and a lot of the other smart people in the ecosystem around. So yeah.
Fantastic. So you had no prior experience in crypto before BitTensor?
No, I was not a crypto bro.
That's wild. And so you kind of share how you got to Open Tensor Foundation, but what was that experience like back in the days, like before DTAO? Like what is it like?
Yeah, I mean, a lot of it. Yeah, so I think there's a couple of different ways that you could approach this, and you could think of it from like a purely academic perspective, which is what I sort of think about, or the way that I used to think about it is like, you have this problem that you're trying to solve, and you want to be able to ensure that you can create the right rule set to get the commodity you care about out of it. And a lot of the language that you'll see people talking about BitTensor subnets today, even just the word commodity that I just used, like, that's not a thing that we ever thought about. Like, you're just trying to get anything to work. You're just experimenting. You're doing a lot of research. You know that people are attacking. You know that people are going to take down your systems, and you know that, you know, there's a lot of naivety. And there was a lot of naivety in the early days, but I think you need to be naive to be able to build big things. Like, if you just thought, oh, obviously this isn't going to work, or this is XYZ, that's going to be difficult, you just end up giving yourself all these priors to not do it, and you would never do it. If you told me like 2 years ago how difficult it was going to be, I'd probably like, maybe not. I think actually, like, a totally side note, but Jensen Huang, who's the CEO founder of NVIDIA, he said, even like in an interview, he's like, oh, if you told me 25 years ago how difficult it would be, I'd tell you just no, I would never have done this.
Yeah.
So we were, yeah, I think those early days are just naive, and they were fun.
That's fantastic. So tell us a little bit about your transition to Macrocosmos. What was it like moving from Open Tensor into like a working subnet, or a team working on multiple subnets of their own?
Yeah, so working at the Open Tensor Foundation, you know, the whole purpose of the foundation was that it was going to dissolve. You know, you want it to be an environment like Linux, right? Like, you don't want one person or one small entity to continue to host everything, or to hold everything, or develop everything. Still kind of like this to this day, but they're getting much better. And honestly, us being at OTF and then transitioning into making Macrocosmos was just part of this process. You know, we knew that this needed to happen. Obviously, you have a lot of internal discussions about, you know, what does the future look like? And it's like, okay, you guys need to go run your own subnets. Well, it wasn't even subnets at the time. It was more like subnet.
Yes.
Here, they were like, oh, go run subnet 1. We're like, I don't know what that means, but okay. Here is subnet 1, and then we just continued to grow and grow and grow, and you can we were able to bootstrap ourselves off the protocol super well, grow to it. Now, what is a team size of about 27, 28 people, running multiple subnets. There's obviously a long history there. But it was mostly based off of necessity that we needed to go make Macrocosmos, and I think we've done a pretty good job.
Definitely. And so before moving into SN9 IOTA, you were working on SN25, Macrocosmos's protein folding project. So I know you talked about having a background in bio, but like what cross-functional skills or like expertise were you able to pull from in that project?
Yeah, this project was so random. Like again, one day Stefan just like showed up and he was like, "Yo, I have this idea. Can you?" Like he basically handed me a code base of like the V0 version. I should say V0.0001 version of it. And he was like, try and make this happen. And actually, I think it was like the best well-suited project for me. Because it was actually no machine learning in that project. And there was a lot more physics intuition than maybe what looks like there to be on the surface. It was a pure experiment into what was BitTensor's first scientific endeavor. Maybe not the most powerful. There are other groups in the space that are doing this, and surely there will be more in the future. But it was like just this concept, like, can you do any real scientific research or build on scientific tooling on BitTensor? And it doesn't have to be machine learning. It doesn't have to be some crazy statistical model. Like, can it be something different? And the SN25 protein folding then became rebranded as mainframe. Was just about this idea of like parameterizing energy. It was like energy is like all be all end all. Can't mess with it. It's the king. And energy tells you a lot about a system, and that was the whole purpose of it. And we were able to show that you could do it. It was possible. It was hard, like everything else, but it was a fun, good adventure, and I do not regret it.
Fantastic. And I think it kind of called back to this kind of like conversation that's happening about like you can incentivize anything. That's kind of what BitTensor is. Like you can incentivize any kind of major amount of work that needs to be done. And you can do it using the platform.
Yeah, definitely. I think this idea of like you can incentivize anything. I think there's like incentivize anything within a reason. I think there's it becomes very difficult to do anything. Mm-hmm. And I think there's beauty in simplicity, and I think that's what 25 did really well on. Like there's one metric of success.
Right.
Of course, there's a bunch of other like heuristics that help you measure stuff and whatever. But at the end of the day, like what we really cared about was a single number, and it was energy, and you couldn't mess with it. Yeah. Like the system just told you what it was, and if they got to energy in the wrong way, sure, okay, that's your fault. You didn't design it right. But there was no subjectivity, right? There's beauty in this. There's something about my physics brain that says like, oh yeah, you can just write down the right equation and it just tells you the number, and you're like, yo, that's sick.
Yeah, that's fantastic. So take us under the hood of Macrocosmos now. Like, so looking from the outside, it seems like yourself and the other engineers that you work with are redeployed quickly to wherever you're most needed. Does it keep the team efficient? Like, what is it like to be working at Macrocosmos right now?
Yeah, working at Macrocosmos is sweet. We have like an unreal culture. I think we have like, this like yes and culture, this like radical candor. We're very honest with each other. And we're all very curious. We care a lot, I think. But most importantly, about the actual like functionalities of the team when it's actually like day to day, like you can't collaborate with everyone. And right now, as we're recording, like having 3 subnets, SN1, SN13, and SN9, we do have teams for each of these. So we don't have strong cross-functional support in the sense of, I'm not bouncing to 1 and the engineers on 1 are not bouncing to 9, but we will inspire each other. And the ways that we designed SN9, for example, is currently helping the way that they design 1. And 13 helps bootstrap data into 9 and challenges into 1. And the way that we think about our product landscape. So as engineers, we do have a lot of cross-functional ideology and we talk a lot, but we don't actually like work on each other's projects, which I think is probably good, maybe.
Yeah, probably. We see a lot of teams come through the space, and for one reason or another, their project does sound amazing on paper, but it doesn't pan out. So aside from maybe this cross-functional aspect, what makes the macrocosmos model so successful in your subnets?
What makes the macrocosmos model so successful? I mean, I guess you could argue there are other subnets that are more successful. Like, I guess this is a subjective thing. You could look at our emissions and be like, oh, you're lower than the other guy, but whatever. I think there's there's, I guess I'm going to reframe it. Like, it's what's successful for us versus what would work for other teams. And those are different. What works well for us is that we have sort of what I mentioned before, is that we are very curious. Like, we care a lot. I think this is underappreciated, is a company cannot succeed and will not exist for a decade if it can't solve problems like ownership, right? If you don't feel empowered to own what you're building, or to build the next thing, or just to go off and solve a problem, that's a problem, right? And I think what works really well for us in Macrocosmos is that we do have this. Or if we don't have it in the moment, we really try and instill it in our engineers, right? Like, everyone tries to have this, and it's a self-reinforcing mechanism. Like, everyone's going to have a bad day. Like, I'm going to be like, oh man, I don't want to do anything. But I think this works well for us. And I think the macrocosmos, the systems that create macrocosmos, like, these sort of like 3 parallel subnets that we try and collaborate with each other. It's not formalized, and this is probably what succeeds for us. We probably could use a little bit more formality, but the ability to just sort of come in and out, collaborate, talk to each other, and everyone is willing, and everyone's super nice. You want to talk to everybody. Like, you're going to have stuff that you get from SN1 gets them put into SN9, and you're going to get, a new book to read from the guys in SN13. You know what I mean? Like, this is what works well for us.
Fantastic. And so on your GitHub, you created Open BitTensor Research, an open source public repository for research articles from the BitTensor universe. I think it's really important to hear about the technological advancements from the developers in the space. Do you have plans to expand it? Will you be producing your own articles about your work on BitTensor?
Yeah, wow. I was not expecting that. Yeah, honestly, it was a little side project that I had one day, which is like realizing that, we need to be able to show people who are coming into the ecosystem that there is a place for this information, and it's centralized, and it's like you're not like going to different teams' websites to try and find stuff. Like, it's just nice to have a central location for these things. There's a little bit of sorry, I guess I'll back up. Like, yes, I would love to add more stuff to it. Macrocosmos is like deeply at its core a research group. We like came out of OTF as a research group. Our flagship subnet SN9 is a research subnet. We've done a lot of different stuff, mostly related to research. There's a question whether BitTensor rewards research, but that's a separate question. I think good subnets and good teams do both, right? You need to build products, you need to do research. Do good research helps build good products. I think these feed into each other. And it's just you want to be able to showcase like how much amazing work that we're doing. Like, that's real. That gets accepted to places like NeurIPS. That gets accepted to other conferences that are in Europe. So definitely, I would definitely like to put some of my own research in there, but maybe when it's actually done and good. Yeah.
Fantastic. So I guess kind of bouncing off of that. So you worked with Dr. Stefan Cruz on the white paper for Subnet 9 IOTA. Can you give everybody a brief introduction to what IOTA is and what it seeks to do?
Yeah, so IOTA is our Subnet 9. IOTA is our technological advancement for training large language models. In principle, they don't have to be language. They can be any large neural network. Our thesis is that you don't have to have one large copy of the model. which is what lots of different groups do. You can have a singular large model that's, on a GPU, and then basically train these things in parallel. What they say is, oh, okay, so I have 2 copies of the model. What I can do is split my data up. I can say, okay, I have 100 samples. I can give 50 to this GPU, and I can give 50 to this GPU. They're both going to learn something, and I can combine these models in some clever way to then get the benefit of having learned them both. This is effectively parallelizing your training process. What we say is that, okay, what happens when models get too big, right? Or even training them, or even trying to put one model onto a GPU just like doesn't become feasible. You might need 2 GPUs now. Maybe you need 5 GPUs. Maybe you need something larger. What is the next step? Is there something that could be created that's the next generation of this, to what we just say discretize a model? So this is what we do. We do pipeline parallel, which is you have you take a model like I described, right? Just say you could fit it on one GPU, but actually what I'm going to do is I'm going to split that model. And I'm going to split it into 3 chunks. Let's say I'm going to give one to me, I'm going to give one to Stefan, I'm going to give one to the guy across the street, and we're going to do the exact same thing I described before, but now we're going to do it between our three pieces, and they're going to do it on their 3 pieces, and do the same thing. Now you question why would you ever do this? Like, this sounds dumb. Like, you could definitely question this. You'd be like, why would you split the model? You had a perfectly good model. Why'd you cut it? The purpose of this is that you could push compute to things that are on the edge, right? You don't need a data center. You don't need a CUDA compatible GPU. You could train on your MacBook, right? That's the thesis. Eventually, maybe you can train on the Nest thermostat in your house that is not using a lot of compute. It would be slow, but you could do it. That's the dream. And then the idea here is that if you look at the integral of all compute, so much of it is unused for training. There's a question of, like, could you just tap into that? And a lot of that is completely unavailable if you just never split the model up into tiny pieces. And that's the thesis.
Fantastic. So this foundational model pre-trainer for LLMs. So I think, like, to me, the most exciting part of it is this, like, swarm training. Like, so can you explain the switch from this? Like, so at the beginning, it was kind of like winner takes all, and then you turned it into this, like, swarm training model. So, like, what was the kind of the thinking behind it, and, like, how does it, a little bit more about, like, why it's better?
Yeah, I think there's a question again. Conditionally, the word better. What does better mean? Is it going to create better models? Maybe, probably not. Like, if we're being real about it, like, there's nothing better than training a model without splitting it up and without distributing it, right? Like, there's low latency, you're going to get there faster, there's less noise, there's all these things. So there are trade-offs. Of course there are trade-offs. Engineering is full of trade-offs. The benefits though are things like this. So this idea of a swarm of bees, a ton of bees. You don't have one big bee, you got a swarm of bees, and all of them are doing a little bit of work, right? If you can coordinate that swarm, that's really powerful, because, again, let's assume everything is perfect. That's effectively one giant compute node. And that's really, really powerful, because they don't need to be in the same place. 2, they don't need to be talking to each other directly, right? So you can coordinate this swarm of GPUs, or even smaller, less capable machines, to do a bunch of work for you. And the only way that you can continue to scale this to smaller and smaller machines is by cutting the model up into tinier and tinier pieces. There's obviously a question of, like, okay, if you go too tiny, then it's too slow, right? The more splits you have, the slower this is. The less splits you have, the bigger your machines need to be. So there's a happy point, right? And I can't guarantee, no one can guarantee that the models that are going to come out of IOTA are going to be, like, the best models or the most competitive models or this or that. That's obviously the goal. But there's no, like, I also just want to preference, like, IOTA in the way that we've made it, like this pipeline parallel, swarm type training, like this is a very, very new thing, right? Like if you look at the number of papers that are out there in research that even touch this topic, it's very, very low, comparatively to, you know, the distribution of all the other papers that you can get. So we have a lot of fundamental research to do. Whether it's going to pan out in a certain time frame, choose their time frame, who knows? But we're pushing really, really hard. I was working up until right before this meeting. So yeah.
Very cool. And I think I guess the one question is like, what are you incentivizing? So of your miners, what are you incentivizing? Is it the training itself, or is it how much compute they're using that they're getting kind of like reimbursed for?
Yeah. So there's the incentivization question is really important. As of right now, it's just straight up throughput, right? So there's a difference between a soft incentive and an explicit incentive, or and a hard incentive. So your explicit or hard incentive is to say how much work can you get done and do it as fast as possible. If you're more available, you do more work, you get more money. That's like a very simple closed form box checkmark type thing. Soft incentives are one, like, okay, how do you optimize yourself, and what is my incentive to do to other people, or how should I optimize where I should put my node, and these sorts of things. Like, we don't enforce this, right? We don't say that you need to be in this data center, or we need to be in North America or Europe, right? Like, you can do it, but it's a soft incentive. Like, it just kind of pushes you in the right direction. But your hard incentive, what you actually get paid for, is how fast are you. So good engineers who understand this will make the right decisions.
Okay, and then I guess my next question is like, what product comes out of this? Eventually, you get like a body of research that hopefully shares that like swarm training is how you should be doing it, for LLMs. Is it like you'll create like a bespoke trainer for corporations? Is it that you'll have this body of work that kind of like people pay you for implementation?
Yeah, the product question is hard. Because it's like you don't actually know exactly what people are going to want. Like, we run on a hypothesis that as more compute is available, more people are going to train more models. Yes. Right? This can feel counterintuitive, because you would think that, like, oh, if people are training this many models right now, if people are training this many models right now, like, oh, okay, sorry, I'm getting a call, right? Let me just check.
Like in a podcast.
Exactly. Exactly. I'm getting a call from Stefan Cruz himself.
Very cool.
Yeah. Sorry. So we can just go take my mind back. So as more compute becomes available, we run under the hypothesis that more people are going to train more models. So under that assumption, there's an opportunity for us to create models. There's an opportunity for us to also use a lot of compute to train a large pre-trained model. So I can't answer your question directly. It's not like an individual quantized commodity that that Shiva's going to be able to use tomorrow. You're not going to be able to use this model tomorrow, but there's a lot of various opportunities for us to build small models, big models, train a bunch of intermediate, small-ish models to make a big model, right? Like, what is our fundamental commodity is like the training network itself. I don't know if we'll sell models. I'm not the guy to say that, but we do have the opportunity to train a bunch of different models.
Fantastic. What is next for IOTA? Do you have something big coming in the pipeline, or just working on most of the same refinement and improvement?
Yeah, we have a lot incoming. Nothing that I can say directly on this podcast, but I'll say very, very shortly, people are going to be quite excited about what we're building. The history of IOTA, it's been very difficult, very tough. Not something that's been easy to get over. We spent like 6 months just engineering the backend for this system, and just really, really burning. And now that we have a working system, it's about like, okay, now what are the possibilities? And this is the fun part, right? What are the possibilities? We have a lot of very cool things coming down the pipeline, stuff that you yourself will be able to interact with. And I'll leave it there, and then I'll message you when it's open.
That's awesome. Very cool. And I think I wanted to talk a little bit about BitStarter because I think it's come up probably since we started talking. But so maybe we'll get into BitStarter. But before that, I wanted to mention that in your pin post on your X account, one of your personal reflections for others working on subnets was to build fast, monitor your subnets aggressively, and break production. Is this the same advice you would give subnet owners or subnet builders another year out? And what would you add to that advice, knowing what you know now?
Yeah, that's so funny. Fundamentally, yes, I agree with this. I agree with this mentality because it's hard to build stuff. And I think BitTensor is one of the only places you have on the planet that allows you to build in such a way where you get immediate feedback and you can just grade it. You can just gradient your descent, the whole thing, right? You can just find it versus if you're just working at a regular software company, you can just find a local minimum of stability and it's fine, right? Until you're you only really find good solutions until you're pushed, right? What's pushed to the limit. And not saying that BitTensor does it every single time, all the time, but you have the opportunity to continually improve, break your systems, solve them up again, let them break again, and keep going. And that's what made IOTA so good, right? Like we did exactly that thing, and that's hard, and it's really, really rewarding. Now, I think it becomes a little more difficult when you're in the detail world, right? Because people are investors and they want to see a certain thing, and the thing doesn't work, and therefore people are selling alpha, and this is a whole other thing. It's complicated. It's complicated because obviously the best thing to do is that you create something that works, and then everyone loves it, and then it's done, and then people are like, oh yeah, you're building the best system. Would I give the same advice to people? Yes, but I would probably give them more caution. I'd probably give them more caution now.
Yeah, the subnet, the alpha owners, I think, have a lot more pull than they maybe used to. It's not just like a research lab only. It's like you also have like stakeholders that you have to answer to and monitor them, as well as your miners, as well as your own team.
Yeah, it wasn't like the pre-detail world where you could get some emission and then just do really good work and not have to think about that. Now that you have to think about that, oh man, it's a little harder.
Okay, so tell us about BitStarter, about your role, and I think the target demographic. So if you're talking to like the dev world, people that are doing really cool things, and perhaps you want to pull into BitTensor and this world.
Yeah, BitStarter is a great opportunity. This is the brainchild of Macrozak. This is Chris Zachariah himself, the head of marketing at Macrocosmos, longtime friends of Will, Mike, and Stefan, very, very close friends with them for like a decade. And he's been working at Macrocosmos and seeing the BitTensor ecosystem evolve and seeing what it is missing. It's a lot of like stewardship. It's a lot of mentorship. It's a lot of a lack of support. For lack of a better word, some extractive type behavior that can happen for new subnets that come into the ecosystem. Those who are who don't know any better, not so dissimilar to what a regular company who would sign some deal they're not very good, or I don't know, you can imagine like a music artist who doesn't really know anything about how money flows, and then they just get totally screwed. So Chris was very much wanting to make the next generation of BitTensor and make something that's like, empowering for people to feel like, oh yeah, like this is the solution that we've been missing, or the answer that we've been missing. So the idea about BitStarter is that making a Kickstarter for BitTensor, right? You want people to be able to pledge to new groups that are coming through through the pipeline, and people who are on the platform have the opportunity to like raise funds, and people who put their capital in, put their TAO in, like pledge with TAO. If the whole raise goes through, as you know, there's a lot of caveats to it, but if the whole raise goes through, they become alpha holders. They get dividends of the owner emission. And this is really cool, because what this allows you to do is from an early stage that you have people who are like, you know, staking into your subnet and want to see your subnet thrive, right? And it gives people the opportunity to like go in front of the audience, tell them everything about themselves, to show their white papers, to explain their motivation, and then in typical BitTensor fashion, kind of just let the market decide. There's a lot of facets to BitStarter, which is about like supporting teams and how you connect teams, and you know that's why we have the whole advisory panel. The advisory panel is meant there to be, you know, a connection to like the financial world, the mining world, the you know, I don't know, the design world, the engineering world, all that sort of stuff. But in principle, this is what BitStarter is.
Fantastic. And so what role do you have on the team as founding engineer? Like where do you plug in?
Yeah, I just do anything that's related to engineering. Like so we've hired a marketing agency and I should say a website agency to help us create it. So they're doing a lot of the engineering work, but I'm like the engineering stakeholder. So I make sure that, you know, that's getting done, and I make sure that the actual crowd loan piece that's happening on BitTensor Substrate, which is like a blockchain based solution, that gets done properly. And I'm working closely with an OTF engineer on this, making sure that like literally with the person who wrote it into Substrate, making sure like, hey, this is right. Like I can test it and you can see it, and this is what I see, debugging and doing that sort of stuff, making sure that like by the time we get to the point where we want to do the first raise, it's like solid, crisp, clean. And then my role will slowly dissolve, right? Like it'll be very much like being involved and, you know, making sure that BitStarter is successful. But my engineering role will change probably into something different. But I'm mostly there to support Chris and his mad journey.
Yeah, it sounds really cool, and I think it is something that's like that was definitely needed in the space. So do you have any, so at like with the upcoming halving, as somebody that's like onboarding these kinds of teams that are coming in, hopefully getting their own subnets, what is a piece of advice you'd be giving them when it comes to the halving? Like hold on, come back in 2 months, or like what is the advice?
I think the practical advice is that just like, well, no one knows. No one knows exactly what's going to happen. Everyone can conjecture, right? Like there in my brain, there is equal probability that the TAO price will double or half, and I don't know what it is. There are some people who are like, oh no, but if you do the inverted BitTensor, Bitcoin, Ethereum model, then this number comes out. You're like, I don't know what that is. So my recommendation is to not get bogged down in the numbers. If you believe in BitTensor, you know, the trajectory is clear. But when it comes to the financial strategies, me personally, I'm much less knowledgeable on this. BitStarter, we work very closely with Ash Wu. Ash is a very prominent figure in like at least the financial space of DTAO. And he's super stoked on BitStarter, and he's in our groups and I believe hired by us. Actually, maybe this is a Chris question. I believe he's actually hired by us. So there are people who believe in it, people who are doing modeling and making sure that like new teams that come into the ecosystem have the resources to know how to deal with the tokenomics and how things are distributed, because yeah, it's a non-trivial problem and a lot of math and a lot of details. And you know, even Macrocosmos, like our CFO, is a decade-long investment banker, dealing with deals of hundreds of millions of dollars. And he's even like, man, this is it can get complicated. Like you just like, so we're gonna try our best.
Fantastic. And so I think I wanted to give a little shout out to like the first team that's coming up. If you want to talk a little bit about Loosh and what they do and why that was like maybe the first choice for BitStarter.
Yeah, I mean, there's a couple things, and so I'll answer your second question first. Is like why they're the first choice. Um, Chris got in contact with Lush very, very early on, and they were one of the first teams, maybe the first team, to believe in the idea and think and really cry from the heavens, being like, oh yeah, like this is what we've been looking for, like this is what we want. So I think a big part of it is Chris has a very high what's the word I'm looking for? He's a very high ownership, and his when he wants to do people right, and he sees this opportunity to do them right because they believed in him and he wants to believe in them, and so he's like, okay, like let's do it, like let's put you on the train, first carriage, and just go for it. So that's a big part of it. I also don't think that he would have done it if he didn't think their idea was good. And so them trying to push in, so Lush trying to do consciousness robotics and understanding the human mind is a very difficult task. They are very smart people. I will say, I haven't done nearly enough work on to understand their incentive mechanism in the deep work that's required there. But they are definitely an impressive team. They have a lot of they've thought very, very deeply about what it means to try and model consciousness and understand consciousness, and this is what they care about. And I hope that they're able to do their careers work on BitTensor.
So cool. Yeah. Okay, so I think kind of zooming way out to finish off today, what are your thoughts on kind of the state of BitTensor as a whole? Do you think that BitTensor is still in its early stages? And then kind of as a follow-up, where do you see BitTensor going from here?
These are good questions. Well, okay. So BitTensor is interesting because I think there are times when you're like, oh, this is the best thing that's ever created ever of all time, and the idea is beautiful, right? Like I think great things are beautiful. Some subjectively, some objectively, objectivity in it. I think it's very difficult to operate in BitTensor when things can move so quickly. Like recently, like 2 days ago, they changed the emission structure. This is not very easy to deal with. Like we said, like tokenomics is already hard, and people's entire business models are based off of an alpha injection system, and now it's based off of an inflow system. Okay, how does that change all my modeling, right? If you go on tau.app and if you go to in out volume, not a lot of subnets have a lot of in volume, right? So, and a lot of this was done very quickly. Like I barely even knew about it. Like as an engineer, like again, like I'm not part of the C-suite of Macrocosmos, but it's like I wasn't privy to this really. And then I look and I'm like, oh, like all of our subnets are gonna have zero emission. That's cool. Yeah. That's a nice, fun little.
That's a today problem.
Yeah, exactly. BitTensor is filled with today problems, not tomorrow problems, not yesterday problems. It's today's problem, not next month. So, this is the one thing that concerns me about the ecosystem. It's very difficult to plan. It's very difficult to. Because of this, it can be very difficult to build. This is my existential worry of BitTensor. I hope that we move in the right direction. I think we're one of the, maybe you can speak more to this because you know more about other crypto ecosystems. I think that we're filled to the brim with intelligence, filled to the brim with like people who actually want to do good work, and we have the resources to make the right decisions in the right ways. I believe in our community. I believe in our engineering. I believe in what we're trying to build. But belief can only get you so far before the system's gone.
Yeah.
So this is my fair warning.
There are definitely other blockchains like easier to build, but like the smartest people I find are like here on BitTensor. So it's like if there's anybody that's going to figure out the problem, it's going to be you all. But it is interesting to see just like from day to day. It's like even as like an alpha token holder, it's like I don't know what the next day is going to be. It's different, but not in a meme coin way, in like a we're building world class like state of the art technology kind of way.
Yeah, but I think like, having conversations like this is important, right? Like it's, even though we are in a circular sort of bubble of BitTensor, like it's even hard, sometimes can be hard to talk to each other, right? And be very honest. Like I think the next I didn't even know the new generation was here yet, but the new generation of BitTensor, this is gonna put a lot of pressure on a lot of teams, right? Like, and who knows? Like maybe in 3 months' time there'll be a different change, or maybe in 2 weeks they'll revert it back. Like there's just a lot of uncertainty. Like I didn't even know this was coming. So there could be a lot more, there can be things that are done better in the ecosystem. I believe in the ecosystem, but it's very easy to do the wrong thing. It's very hard to do the right thing.
Right.
And so I give grace where grace is given, but where grace is needed. But this one wasn't good for me.
Okay, I probably clogged up your inbox a little bit.
Yeah.
So I think it kind of leads into my last question, which is like, I think another thing that's missing on BitTensor is like hearing from devs. A lot of times we have really great subnet owners and subnet like C-suite teams, like team leaders that kind of get obviously a lot of very warranted kind of limelight, but it's very important to also hear from the people that are kind of building this thing out. So can you explain in your own words, for somebody that has no idea what BitTensor is, from a dev's perspective, what BitTensor is to you, means to you, what you think it is?
Whoa. Yeah. I think BitTensor, what it is it's a forcing function. Like forcing you to be better. It forces you to engineer better. It forces you to think differently. And I haven't found that many things in my life that have done that. So I think that's, if I look at things from an objective truth, like that's probably like one of the best things that's been given to me. And so I want to shout out to the creators of the ecosystem for that. I think philosophically, it's the right place to build. Again, going back to what we're talking about, like I worry that it becomes unsustainable to build on it, but I think it's the right place to build. Building out in the open, or as open as you can be, with good people, a tight ecosystem, an aggressive mining group. Like BitTensor gives you all the good and all of the bad. It's very hard to balance, but I think it's for the good of everybody that we can build like this. Like just thinking about that. This is potentially 128, or however many subnets are, 128 projects or companies that would have never existed before. Right? That's an awesome thing. It's a great thing. I've made lifelong friends doing this. Right? What a crazy idea. If my mom didn't even understand that I studied physics, she would not understand that I do this.
Yeah.
Right. So I keep coming to this thing. It's like, I think things like BitTensor are beautiful. I think these are the right things. Like the right things to be building and putting your time into are simple and beautiful and great. BitTensor is as complicated as it is simple. And I think that's a good thing. It's taught me to think about incentives of like everything around me. Again, all of this sounds stupid. I don't know. To me, you have like stupid moments where you're like, oh yeah, I guess everything in your life is an incentive. Like you like smoked a joint or something. You're just like, oh my God, like this is so crazy, man. But it's true. Like you think about the incentives of what's around you all the time, and once you frame your brain in that way, a lot of the world starts to make a lot more sense to you.
Yeah.
So it's, if anything, it's taught me that.
Wonderful. Well, thank you so much, Brian, for all your time today. And we're really thankful for your time and your expertise. And we're really excited to see what you do next.
Well, thank you so much. This is great. Appreciate it.